Hey everybody, welcome to Madden Science. Today we're going through Vernier's video analysis app so we can look at motion. In particular, we're starting off just looking at motion that is, as best we can, constant. In order to do this, you're going to need the link that we've provided you, along with a camera and your body. And it might help to have some wheels or a way to move in a different way. So starting off with your phone, you want to make sure that the motion you're filming is filmed horizontally. In addition to that, you're going to want to make sure you go into your settings, as you can see here, and scroll down. And once you get to camera, you can see that there's all sorts of different settings. You want to look at formats. And while I normally keep it at high efficiency, we're going to go to most compatible in this case. That'll help for ours. Now, you can then pull up that app on your phone and click on the import a video. And from there, you can take a video, you can browse a library. You can also pull up videos that they already have here within the app. Now, the idea is that you are going to be using your own videos that we use either in class or at home. Now, that's just an example you can see here. All right, back to the computer. All right, so once you jump into the app on your computer, you can import some video. So here's what you see left over from before. I'm going to click New Experiment. I can save that if I want. Right now, I don't need to. It gives you the option of pulling in previously made ones. The beauty of this app is you make the content. Again, make sure you're following instructions with your phone and film in this direction. I'm going to go in here and give us two different tabs. I'll pull in and take this apart. You can see in here we've got a few other points. I'm going to go New Experiment on this window too. Don't need to save. I'm going to import two different videos. One is the full, and this shows 4 different setups. You can see one walking across, one walking backwards, and skateboarding. 2 different skateboarding. In this one, if we pull in one that I made, it's split, so it shows 2 videos to then do a comparison. And we'll have access to this during class. Keep in mind there's some questions, kind of a chronological order of questions in the description. I want to make sure that you're answering questions that I posed during the video, but also going through the questions in there as we not only take the video, interpret the video, but then analyze it. Hence the idea of video analysis. In this case, we're trying to look at what's going on with distance versus time and velocity, and how is our velocity changing, and how does graphing work, what is our slope, etc. Let's look back at this first one. So here's how you're going to work with this video. We've got this. I'm going to scrub all the way back. Start at mainly the beginning. I can start right around there. We're going to need to set our scale. So I'm going to click on System. I'm going to go in here, click on the meter stick, pull this guy over, and make sure that this separation on there is equal to the meter stick that I had out there. Now, you could conceivably set this up if you didn't have something to measure but you knew your height at your height. And I know if I click here, my height is 6'2", so that would be 1.88 meters. You could, I guess, in this case, if you knew that this was 10 feet, you could do the basketball hoop too. Either way, we're going to go with our most basic 1 meter here. And that will allow our graphs to then be measured in meters. All right, I will then click the Add button. And I'm going to track the movement of me. So I click on my ear, which is a point that's not moving all that much. Once I click, it'll move the video forward by 1 frame. But that's not very much. So I'm going to click down here on the gear, and because this video is rather slow, I'm going to change it to 5 frames every time we advance. Now, if you have something really fast, you might want to go frame by frame. All right, so I advance this one more, and track it by clicking on my ear. Again, better to use your ear in this case than say your foot, which is moving all around. Your eye would be fine. Again, something that is as consistent as possible. Then as I click, it advances forward and we can start to notice some kind of pattern. What kind of pattern are we noticing here? Go ahead and write that in your notes. Note too that the pattern is not just here on the video, but also the data table and this graph. I'm going to add a few more points. You're going to want to add, I don't know, maybe between 10 and 15 points. In this case, you're starting to see the pattern both in blue, but also more clearly on the graph. Now, you can click off the video, you can click off graph, you can get your data table, you can do just the graph. In our case, let's look at just the graph. And we have on our y-axis, x and y, the distance in meters. I'm going to click off y because that's just the up and down. We're just concerned with the horizontal right to left, or actually in this case left to right. Now as we do that, we can also click down here and go for apply curve fit. That looks pretty nice. So this does a lot of the work for you, and you get an equation of a line that is y equals mx plus b, and the slope is equal to y divided by x. In this case, that's our x distance divided by time, and that equals 1.569, and the units are your y divided by x, which is meters per second. That's how fast I was going. And because this line is pretty straight, it shows that my pace was rather consistent, and I tried to do that. Now you can also click on here and see what my x velocity was. Now, if I was keeping at the same pace, that would mean my velocity wasn't changing. What does that mean in terms of your acceleration? So go ahead and pause it. Write down what you think that non-changing or constant velocity means for your acceleration. All right, I'll tell you. It looks like from here that the slope for that guy is negative 0.04536, which is basically zero, which is showing that the velocity stayed, and you can click on these points. The velocity was 1.62, 1.65, and if you go from one to the next, you can see that it was pretty much 1.6, 1.5. I slowed down a little bit, but was fairly consistent. And you can pull all sorts of data from this. So when you do this, you're not only answering the questions I'm posing now, but you're going to answer the questions that are listed in the description. All right, let's look at comparing these two. So I can go back and look here at just the video and data table, and I could compare blue and then walk in the other direction and then skateboarding. That would be all fine. For now, I'm going to compare them directly. So I put these side by side. I'm going to start it here. I'm going to start it here as two different objects. So I can add my system, so my reference points at 1 meter, and then I can track, we're going to call person on the left object 1. And I'm going to advance frames every 5. So I'll advance one forward, click on the tracking ear, again. So I want you to be drawing out this graph in your notes. It doesn't have to be perfect, but make it representative of what you're seeing. So I want it to look like this. You don't need the numbers in there, just the overall look. Okay, now this is a new thing we're going to do here. I'm going to back it up. And I'm going to add an object. So I click on the object here, and I'm going to add new object, change the color so it's a little bit easier to see. I don't know, like where's like a hot pink? Actually, we'll go over here. Just make it red. All right, and I'm going to click on this guy. Oops. Make sure I'm on object 2. So I click on object 2. I'm going to name this guy object 2, and look, I can then chart walking in the opposite direction. So what do you think that graph will look like? What do you think the slope will look like? And how can you compare the two velocities of these two walkers? Go ahead and write that in your notes. All right, as we continue, you'll see I can add these points. I'm going to add one more. So then I'll be, actually we'll do one more, off the screen. And look, we've got a data table. So pulling that up, I'm going to turn off the video. And the data table, look at the graphs. Now you can see the Y's are in the middle. And the Y's are just how up and down the motion was. So I'm going to turn that off for both. So we've got X and X2. If I click carefully down here, I can apply a curve fit. Hey, that looks nice for both. Please draw this in your notes and make an observation as to the steepness of those curves. One is going up, one is going down. We can see our slopes. So we had this slope before. Slope for our red line going up, which is object 1, is a positive 1.498. And the kind of greenish one going down is negative 2.15. So it's faster. We could see that walk in the other direction was faster. And it shows it here from our equation where the slope is how fast. And the slope in units, they don't show it on here, but those units are meters per second because the Y is in meters and the X is in seconds, and slope is change in Y over change in X, or Y2 minus Y1 over X2 minus X1. Okay, let's kick the video back over. All right, next thing we're doing. Okay, if we click through we can see that skateboarders are up next. What I need you to do is go into the video description, answer those questions in your notes, and then pull up your own videos, and we're going to compare the different movements that you had in class, and then we're going to compare these two skateboarders at the same time. When you have questions, definitely put in a comment below and let me know what I can help you with. Take care, everybody.